All right, we're doing the first lesson of chapter 4, and it's radian measure. So by the end of today, you should be able to explain how radian measure is determined. You should also be able to convert radians to degrees and degrees to radians, and you should also be able to determine the arc length and the angular velocity in real life situations. Here we go. Radian measure, here's the definition. The radian measure of an angle theta is defined as the length A of the arc that subtends the angle divided by the radius R of the circle. What does that mean? Well, if we look at this circle, it has a radius R. So there are two lines here that are forming, or these aren't lines, these are kind of line segments that are forming this angle. Each is the radius of this circle. This distance right here, whoopsie, it's in black. This distance right here is called the arc length. Okay, it's the length of the arc between this radius and this radius, and it is then the arc length is formed by this angle theta. Okay, so what a radian is the length of the arc divided by the radius, and whatever that value is, that is how we would measure that angle. So radian measure is just a different way. It doesn't use degrees. It's just a different way of measuring angles. Arc length divided by radius. Okay, well, let's think about it in terms of going all the way around. So if you go all the way around the circle, that's the circumference of the circle, and that is 2 pi r. So the arc length is 2 pi r. And if we divide it by the radius, then we're going to get theta equal to 2 pi. So you should be comfortable knowing that 2 pi is equivalent to 360 degrees. And if we know that, then we know that, of course, pi, if you divide both sides through by 2, is 180 degrees. Okay, and pi is halfway around the circle, so 180 degrees is pi. If we look at it and we break it up even further, if this is, there's our, the radius. So if I form this angle from here to here, that's going to be half of pi, which is pi by 2, we say. When it's divided by a number, we call that pi by 2. This would be pi. This would be 3 pi by 2. And of course, if we rotate all the way around, it's 2 pi. And again, we are rotating in a counterclockwise direction for positive angles. Okay? All right. Let's convert radians to degrees. So we already know that 2 pi is equal to 360 degrees. So that's 2 pi radians. If I divide through by 2 pi on both sides, then what I get is 1 radian is equal to 360 divided by 2 pi. Or 1 radian is 180 divided by pi, if we simplify. Okay? So if we have 1 radian is this many, if we have 50 radians, then we're just going to multiply 50 by 180 over pi to get the exact number of radians. To get the approximate number of radians, we would take the 6.28, which is 2 pi, right? Pi is 3.14, so 6.28 radians. Divide both sides through by 6.28. And we would end up with 1 radian is equal to 360 over 6.28, or 1 radian is equal to 180 over 3.14. So if we're looking at these are very similar. This is exact because it's in terms of pi. This is not exact. This is approximate because it's using 3.14. So if we were converting from radians into degrees, then we would, depending on which what we want, whether we want an exact answer or an approximate answer, we might use one or the other. Okay. That's just the bottom of that. Converting degrees to radians, well, we know that 360 degrees, again, is 2 pi radians. If I have 1 degree, so if I'm just dividing this by 360, then I get that 1 degree is 2 pi divided by 360, which simplifies to pi over 180 degrees. So now that's what 1 degree is in radians. So I would multiply whatever degree I'm trying to convert, say it's 50 times pi by 180 to get the equivalent in radians. And again, we're going to do that for exact, pi by 180. And for approximate, we're going to use, instead of pi, we'll use 3.14. Okay. That's one way. We'll do some examples in a second, but so that's one method to use to convert from degrees to radians and radians to degrees. Or you can use this other method, a proportionality statement. So we know that if we have degrees and we're trying to get radians, then we would have x degrees over 360 is equal to y radians over 2 pi. These are equivalent, right? 360 degrees is the same as 2 pi. So as long as you match up degrees to degrees and radians to radians, you can fill in 3 of the 4 pieces, and then you'll solve for the other one. This is the exact one. You're going to have it as 360 and 2 pi. Approximate, you would use 360 and 6.28. So let's do some examples. So I'll do it 60 degrees to radians using our multiplication method. Now, I'll just simplify here to, maybe just up here. So if we're going from, we have this, you may want to memorize this. I don't know. I don't usually memorize things. I try to understand them. But so if we want to go from degrees to radians, we're going to multiply by pi over 180. That's the exact. Or if you want to multiply by 3.14 over, there's a point in there, over 180, that's the approximate. If you want to go from radians to degrees, do that in red, no, I'll do it blue, radians to degrees, then you're going to multiply by 180 over pi. That's for the exact. Or you can multiply by 180 over 3.14. And that's, oopsie, I should have done that in red, sorry. And that's the approximate. Okay? So you got to kind of either commit to memorizing that, or you can use the proportion statement. And right now, I'm just going to use the formula. So we want to convert theta equals 60 degrees. So we're going to convert that to radians. So we know that theta is equal to 60 degrees times pi over 180. You don't need to put the degree symbol in there. Now, you're just going to simplify this fraction using your calculator, and this is going to be pi by 3, or 1/3 times pi, but typically we write it like this, pi by 3. That is radians, and that is exact. If I wanted to do approximate, I would say, using the same method, theta is 60. Theta is 60 degrees times, and instead of pi, 3.14 over 180. And I don't have a calculator. Maybe my iPad will work. Let's see how. too long to find it. Okay, so I'm just going to take 60, it's basically 3.14 times 60 divided by 180, and that's not giving me the right answer. Try that again. 60 times 3.14 input divided by 180. 1.05. So this is going to be approximately 1.05 radians. So you should really have a good idea in your head of what 1.05 radians looks like. Okay? And if we just take a second to think about that, I'll just put up a blank page for a second. 1.1 radian is really going to be, if we think about the circle, we think this is 0 radians, this is pi by 2 radians, this is pi, this is 3 pi by 2, and then onward over here to 2 pi. If we if we took pi by 2 and we literally put in 3.14 divided by 2, that's going to be greater than 1, right? 3.14 divided by 2, greater than 1. So it's going to be, I know 1 radian is going to be between 0 and 90 degrees. If I broke this into thirds, then each of these thirds is going to be a pi by 6, right? And if I had 2 thirds, then I would have 2 pi by 6s, which is, of course, pi by 3. So pi by 3 is going to be pi divided by 3, which is about 1, right? 3.14 divided by 3. So 1 radian, which is a little slightly bigger than 1 radian. So 1 radian is about 2 pi by 6, which is pi by 3, and pi by 3 then is 1/3 of this. So this, is 2/3 of this. So we've got 1 pi by 3, 2 pi by 3, and each of these thirds was a third of 90 degrees, so each of these was 30 degrees. So this was 60 degrees if we want to think about it in degrees, which was just slightly bigger than 1 radian. Okay, so I would say that you should know in your mind, have a little reference point. We do know obviously that 2 pi or 6.28 is equal to 360 degrees, but 1 radian is approximately 60 degrees. All right, so let's go back. So I got an answer here of 60 degrees, and I got 1.05. That makes sense to me, given what we just looked at, okay? If I wanted to use the proportionality method, then I have 60 degrees over 360 degrees equals x radians over what matches with 360, 2 pi. This is going to give me, when I cross multiply, this just method is helpful if you don't want to memorize the pi by 180 or the 180 over pi, just in case you get it mixed up. So this is going to be 120 pi over 360. This reduces down to pi by 3, okay? So which is what we got here. So this is pi by 3 radians. So that's the exact, and then if I were to do this for approximate, I would still have my 60 over 360, and instead of having 2 pi here, the equivalent in radians is 6.28. Cross multiply, 360, whoopsie, x equals 60 times 6.28. 60 times 6.28 is 376. So we need a little dot here. 0.8. And so x is equal to that divided by 360, which is again about 1.05 radians. Okay, so you can use either method. I'm never going to tell you which way you have to do it. Either way is fine. So now I want to convert an exact radian measure to a degree measure. So I am going, if I use my typical theta equals 2 pi by 3. So I could have used theta there. I used x. It's fine. So theta equals 2 pi by 3, and so theta equals 2 pi by 3 times, instead of pi over 180, because we're going the other way now, we have 180 over pi. And what should happen is if we're getting an angle in degrees, our pi's should cancel. We get 360 divided by 3, so that's 120 degrees. If I wanted the approximate answer, I'm going to get the same thing because, well, it's just, I shouldn't say that, 2 pi by 3. Theta equals 2 pi by 3 times 180 divided by 3.14. Theoretically, if you're going to put in 3.14 here, you're going to put in 3.14 here, which means that you're going to end up with 360 divided by 3, which is 120 degrees. So you're getting an exact answer again. If you start with if you're doing the proportionality method, you're just going to say 2 pi by 3 over 2 pi is equal to x, or theta, over 360 degrees. Cross multiply, 2 pi x equals, when I multiply this, I get what? 720 divided by 3 is 240, and pi. I'm going to divide both sides through by 2 pi now, and when I do that, I get 120. My pi's cancel, and I'm in degrees. This is going to give me the same answer as if, instead of using, you wouldn't do this normally, you're going to do it with 2 pi because your pi's will cancel, but had you done this, it should still work. You're going to just say 6.28x equals 240, and then you could multiply through by pi, which is 3.14 here, or you could just leave it and say this is going to then be, divide this by 2, this is really 2 pi, right? So divide that by 2, it's 120, and the pi's should cancel. Because you're using an approximate value, you might want to stick an approximate sign there, but technically it's exact. 2 pi by 3 is an exact value. Okay. You getting it? Oopsie. So now, why don't you try converting 4.32 radians to degrees? Just pause the video, give it a try, and then come back and see how you do. So if I've got 4.32 in radians, I've got 6.28 equals x in degrees over 360. Notice I chose to use 6.28. I didn't use 2 pi because 4.32 radians, it doesn't have a pi in it, so it is approximate already. Okay, as soon as you don't have the pi, you have an approximate value, except for maybe 0. Okay, so I'm going to just cross multiply 360 times 4.32. That's big. 1555.2. So I'm going to use an approximate sign all the way here. and then x when I divide through by is 247. Let's just leave it at 248 and round up to the nearest degree. Okay. Let's think about whether this answer makes sense. So if I've got 4 radians, well, 1 radian was about 60 degrees. So 4 radians is about 240 degrees then when I multiply 60 by 4. And so if I have 4.32 radians, it should be greater than 240 degrees. So, sometimes you just want to make sure that you really understand what those numbers mean, because they're very, right now, 4.32 is so abstract to you in terms of what a measurement of an angle is, right? So just double check your understanding, or your answer with your understanding maybe from 1 radian equaling 60 degrees. Okay, so arc length. We already told you at the very beginning that angle theta is formed by the length of the arc divided by the radius of the circle. So if we rearrange that formula, we get, when we cross multiply, the arc length is equal to the radius times the angle in radians. So for this example, we can actually ask for the arc length given a radius and an angle. Okay, this is an angle, right? 1.7 radians is a measurement of an angle. So I would say A equals r theta. I'm going to say A equals r, which is 4.7. That's our radius, times r theta, which is 1.7. Now this is an approximate value, so our arc length is going to be approximate. And I'm just going to multiply 4.7 times 1.7 and get 7.99 approximately. 7.99. A is an arc length, so we're going to go back to our radius to see what our units of measure are here, and they are centimeters. This formula, arc length equals radius times radians, is only useful if our angle is measured in radians. So if we are given an angle in degrees, we have to convert it. So let's say theta equals 64 degrees. Therefore, theta is equal to 64 times pi over 180. And if you simplify that, 64, 4 divided by 4. Hey, I don't have a fraction key here. 16, 180 divided by 4. So 16 over 45, is there any number that goes? So this is 16 pi over 45. That's the exact radians. And so if I wanted to now find the arc length, I could say A equals 16, R is the 4.7, we'll put that in first. And then I could say times 16 pi over 45. Now, because I need a length, and I've already got a decimal here, I'm just going to keep going. I'm not going to get it in terms of an exact arc length in terms of pi. I will just get an approximate value. So this is going to be 4.7 times 16 times 4 divided by 45. 5.25. And again, this is centimeters. Okay? So had this been something like 5, for instance, we could have gotten an exact value. So let me just show you. If I didn't want to substitute in for pi, I could have said, if this is 5, if 4.7 was 5, we could have said 16 pi over 45. And A then would be exactly 16 over 9, 16 pi by 9 centimeters. So now we're talking about lengths in terms of pi. Okay? So that's very interesting. Okay. Angular velocity, super easy notion. The angular velocity is the rate at which, if one arm is rotating, it's how the angle is changing as one of the arms of your angles is rotating. Okay, so we can talk about angular velocity in terms of degrees per second. So what is the rate of change of the degrees over time? Or you can talk about it in terms of radians per second. Okay, what is the rate of change of radians over time? So let's look at this example. And I mean, you just want to say the general equation then would be the velocity is equal to the angle divided by the time, basically. Okay, so the hard disk in a computer rotates at 7,200 revolutions per minute. So this is giving the revolutions per minute and not the degrees per second. So we have to change it from revolutions per minute to degrees per second. Well, if we have 7,200 revolutions, that angle then, the angle that it makes if it rotates once is going to be 7,200 times 2 pi, which in this case is in degrees, so we're going to do 360. Okay, so that's the angle that the hard drive makes in 1 minute. It's rotated that far. So 7,200 times 360 degrees. Ooh, that's a big number. Okay, so that's 2,592,000 degrees in 1 minute. But we want to know the degrees per second. So we're going to say theta. Not theta, sorry. That's theta. This is the velocity in degrees per minute, and the velocity is going to be 2592000 divided by 60 seconds, and you're going to get the velocity is 43,200 degrees per second. Okay. Should put a little conclusion there for the angular velocity of the hard disk is 43,200 degrees per second. That sucker's rotating pretty fast. Okay, now let's get it in radians per second. So again, our angle is going to be, we probably should say, let theta represent the total angle rotated, in this case in degrees. And over here then, let's go to red. Let theta represent the total angle rotated, not in degrees, but in radians. All right, so then we're going to say theta is going to equal 7,200. Instead of 360, every time we rotate, that's 2 pi radians, right? So that's going to be 14,400 pi radians. And then we want to get the velocity. So that's going to be 14,400 pi radians per 60 seconds, or 1 minute. And then if we want to get the radians per second, we're going to end up dividing just the 14,400 if possible. 14,400 divided by 60, that's 240 pi radians per second. That's the exact angular velocity, and if I had asked you for the approximate angular velocity, you would just substitute in pi. Use your calculator, pi. I'm just using 3.14 because I'm using my iPad as a calculator, but generally you should be just using calculator pi, so just so that we're all kind of on the same page with our answers. So approximately 753.6 radians per second, which would be the approximate. Therefore, the angular velocity of the hard disk is 240 pi radians per second. Okay, some people say that you don't need to use units for radians. I prefer that you actually put the radians in. So I'm always going to expect that you have the radians there, okay, for sure. All right, that's it. Enjoy your homework.